All right, so we got 8 guys. Quiet, please. Thank you. Okay. We got 8 tenor functions: x squared, x cubed, x, absolute value, root x, whatever x, e to the x, which is exponential, which you're going to focus a lot today, and then a circle: x squared plus y squared plus 1. Okay, when you're asked to find the inverse, you're simply just switching x and y and solving for y. That's all you do. So I'll do part A right now. Yeah, go ahead. Go somewhere. Oh, sorry, part 1.
4.
I'll get there in a moment. We'll just go in order. Okay, so when you get y by itself, very important, you have to put plus or minus when you square root. You have to put plus or minus. For 2. Yeah, look, go ahead.
I think it was my homework packet.
Yeah, you're the slacker. I knew it.
Startles.
That's your handwriting? Yeah. You're good. No, last eight. We didn't have to kill any trees. Let's get a new one. All right. Okay. Now, when you get y by itself, do you have to put plus or minus, or does it not matter? Does not matter. You don't put plus or minus because it always comes out as, it can be positive or negative. It doesn't really matter the final result. So you just put cube root of x. It's when you even root, you have to put plus or minus because you have to guarantee when you square it. But if you put a negative out in front and cube it, then it could be negative afterwards. That could be a problem. So we don't want that there. 3 just is what it is. Switch x and y. Just stays the same. 4 is kind of a funny one. Yeah, now you're asking about that some more. So that's going to be x equals absolute value of y. So what that really means, I haven't really talked about this. It's something called a piecewise function, but it's okay. I'll just write it like this. It means that y equals, yeah, you know, I'm going to write it like this. It's kind of a funny situation. It can't get scary. It can't. I know. But I do want to be proper. I want to go over this a proper way. Okay, this is what we call a piecewise function. It's kind of weird. Actually, am I doing that right? Hold on a second. You know what? Ignore what I just wrote. Ignore that. Just leave it like this for now. Here, just ignore that new stuff I wrote. Just leave it like that. Just leave it like that. We'll worry about that later when we do the graph. Yeah, just leave it like that for now. I just realized that's probably okay. What I'll do before I do 5, 6, 7, 8, let's graph 1 through 4, and then let's cycle through 5, 6, 7, 8. Okay, for the graphs. I'll do the sketches and I'll discuss afterwards.
Are we only graphing 1 through 4? Or are we doing
Only graph 1 through 4, then we'll do 5 through 8 afterwards. You guys be careful with the boards. Thanks. It's a little distracting. All right. Okay, 4 is kind of a funny graph. All right, there we go. All right, see you, Nathan. We'll see you. Okay, what's happening here? Okay, so y equals plus or minus root x. Now we know what y equals root x looks like. It's the top half of like a sideways parabola. So that's y equals root x. But because it's a negative, you have to also graph its negative counterpart, which is root of the x-axis. So combined, it looks like a sideways parabola. Also, the fact that if you graph the original, I'll do the original in blue because I think that's going to show up well. If I graph y equals x squared, it looks like this. If I graph y equals x cubed, it looks like this. If I graph y equals x, it just overlaps. And I graph y equals absolute of x, it looks like this, where it's a bit of an overlap. Can do a little better. Okay, 3rd time's a charm. There we go. And if I were to do the y equals x, If I do y equals x, I'll do the dash green. Notice y equals x goes to the middle of each of these graphs, right? Definitely for 1, definitely for 2, definitely for 3. Well, 3 coincides with it. 4, that cuts that in half as well. So that's what's happening there. Now, how do I know how to do these graphs? Well, again, this one was y equals plus minus root x. Y equals root x is just the top half of the red curve, but you have the negative part as well. Cube root, we kind of talked about if you were to switch x and y values, you get a shape like that. Y equals x, obviously you retrace a line. The algebra is a tough one. Now, if you think about it, if x equals an absolute value, will x ever be negative? No, right? Because absolute comes out as being positive. Just like when y equals absolute of x, y is always positive. Now it's the reverse here. X is always positive. So y can be whatever. So that's why it's gonna be that right side. It's like a V rotate 90 degrees. So you can rotate 90 degrees, the V shape. So that's how those 4 look. All right, any questions about parts A and B for those 4 equations? Okay, there is a part C and D. Let's answer part C and D for these 4 as well. And then we'll cycle through parts A through B, sorry, A, B, C, D for equations 5 through 8. All right, so let's look at part C. Let me clear this out. Are any parent functions their own inverses? Yes. Y equals X. That's because it's the same graph. Do any parent functions have inverses that, sorry, do any parent functions have inverses that are not functions? Yes. That was y equals x squared. And y equals s 5x. That's because the originals fail the horizontal line test. Or the inverse fail the vertical line test. Horizontal line. So a horizontal line test is when you draw a horizontal line, and if the horizontal line passes the graph more than once, it'll fail. Which it does for y equals x squared and y equals absolute of x. Hence, the inverse won't be a function. Or you can apply the vertical line test directly to the inverse. The vertical line test, if you draw a vertical line, if it touches more than once, it fails. When I drew the inverses for y equals x squared and y equals absolute of x, those vertical lines failed. It cost more than once. That's how you have to look at it. So again, just draw a horizontal line to the original. If it fails, means pass more than once. Its inverse won't be a function. Or to look at the inverse itself. If you have to graph the inverse, look at itself. Draw vertical lines on the inverse. If it passes more than once, it fails. So there's 2 ways you can look at it. Okay, so that's equations 1 through 4, cycling through parts A, B, C, D. Any questions? Nope. All right, let's go through 5 through 8. All right, 5 through 8, let's find the equation inverses, let's graph them, and then let's do C and D as well. All right, so let's go back red again. I know you might need a little more space. Okay, for 5, x equals root y. So y equals x squared. Here, x equals 1 over y. So xy equals 1. And it gets back to the same thing. That's for 6. For 7. X equals b to the y. Let's leave it like that for now. Because we're going to explore it on the page 13 today. And here, well, big deal. Just the same thing. If you replace in a Desmos, it would just be a circle. And guess what? Circles are very symmetric about y equals x itself. So it doesn't really matter. By the way, for this one here, for 5, you will have to restrict the domain, meaning it's going to look like this. I'll explain why when we do the graph right now. So I do the graph right now. Y equals root x looks like this. So that's only like half of the curve if you think of it like that. So the inverse will be this. That's y equals x squared. However, you have to restrict the domain. So it's in line with the original graph. So I have to do that. So it has to be restricted. Because if you graph y equals x, we get a full parabola, but look at the original graph. That's just like half of a curve, like the top half of a sideways parabola. So you only just see half restricted. If you think about it, this is actually a nice little segue to what we're going to talk about later today. If you look at this, what's the domain for a radical function? We talked about it before. Remember, a radical function looks like this, right? What's the domain for that? Can can x be all real numbers? Only x is greater than or equal to 0, right? And look at y. Y is greater than or equal to 0 as well. You need the same thing for the inverse. And actually it switches. But it's still going to be the same thing. It's still going to be x greater than or equal to 0. So you have to guarantee that result. That's why we restricted domain. So because whatever domain range you get for, so the key things that domain range swap for inverse. So wherever we get for the original, you swap it for the inverse, meaning that we're gonna have to go with greater than or equal to 0 for the y equals x squared graph. We have to. We have no choice. And y equals x goes right through the middle. So that makes sense. Okay there, right? Cool. Okay, 6. That graph is just gonna look like this. And its inverse is gonna be the same thing. Because this y equals x already go right through the middle of it as it is, right? So if it's already going right through the middle of it, then yeah, the inverse is itself. It's the same thing. If we look at the next one, number 7. Correct. Let's look at the original graph. You do know the original graph will look like this. It's exponential. If you plug in 1, you get like whatever b is. So for example, what if y equals 2 to the x? So now x equals 2 to the y power. So what's going to happen, I'll go color. Let's do something that stands out. Let's do purple. Which, by the way, is something we're going to talk about. You guys are going to be interested in a very new concept. And it's crazy that 5 people are missing. This is actually a very important concept we're talking today. Talk about this. It's called a logarithm. You guys probably heard about this. It's a big deal. It's the first time you're hearing about a logarithm. So we'll talk about that later today. But if you were to switch x and y, because if you look at the blue curve, the purple's the inverse, the blue's the original. Yeah, actually, sorry, I know I should have let me color code better for you guys. Here we go. The purple's the inverse, the blue's the original. If you guys can tell from where you're sitting. Lastly, for 8, that's just a circle. If you're plugging a Desmos, you get a circle. And circle itself with the center of the origin and radius of 1, that's just going to be its own inverse. Oh, actually, I did a pretty good circle there. There we go. And there we go. So yeah, just goes right to the middle. So these are more inverse. We're really going to focus on 7. We're going to be very intentional about that today. Okay, so if I look at part C, part C is, are any of their own inverses? Yes. That'd be true for 6 and 8. Explain how you know, because y equals x goes right to the middle of it. Or its inverse is the same thing. The inverse is the same graph. Can I move the screen?
It's 6 and 8.
6 and 8, yes. Correct. So y equals 1 over x. And x squared plus y squared equals 1. And that's because, again, y equals x. Is already symmetric. You could use that same explanation for 3 as well. About those graphs. Okay, you guys can see pretty well. And then do any parents have inverses that are not functions? Actually, I think all of them. Oh, the circle. Circle's not. That fails horizontal line test. All right. Okay, let's move on to page 12. All right, I'm going to give you guys a little bit of a head start. Kind of give you some. This is like very nice discoveries example. Okay, we'll head start. What I want you to, and I'll walk around and help you guys out. What I want you to do is make a table. I want you to plug in -1, 0, and 1. I want you to do the graph. That's super easy. There is a horizontal asymptote. Keep that in mind. Okay. There is a horizontal asymptote. I do want you to give me the domain and range. And then the inverse, you're going to do x equals 3 to the y power. Don't need to solve for y. Make a table where you'll swap from part A. And then graph it, of course. And then get the domain and range from your graph for part F. Okay, I'll give you guys a few minutes to do that. I'll work it out right now. I'll freeze the screen. You guys can't see. It's 1. It's 1. What happens when you do 3 to -1, guys? Good. Awesome. I'm gonna ask you guys to start getting the habit of doing interval notation. We kind of have to start doing that because you guys are just a few months away from pre-calculus where interval notation is kind of the only way you state it. So I'm gonna start doing that and help you with that if you do get stuck. Good. Bracket is one that, so including me. Brackets included, so we're gonna use parentheses in this case, because not included.
What if it's like a, like in this case, what if it's greater than 0, you still just.
You do parentheses 0, comma infinity. Yeah, because you're going towards infinity.
Wait, what is interval notation? It's like, oh, it's something.
Parentheses or brackets. Yeah, I'll show you guys in a moment. Forgot.
When there's an asymptote, you put like a U thing in between. I don't know, it looks like a U.
That's if you have two, that's for the rational, that's one for one over X. We have two brands. We don't have that here.
But like just.
Right, of course, right. The domain range will swap. Yep.
So the domain is gonna be 0, infinity, and the range is. gonna be-
Yes. Good. Yes.
Wait, but if it can be any value, what do you do for interval notation?
Negative infinity to infinity. What's all real numbers? You do negative infinity to infinity.
And both of them are things back there, like.
Parentheses. Yeah, because infinity is an abstract concept. We don't know what it is. And zero's not included. All right. Any questions so far? All right, let's talk. If you're still working on it, it's all good. All right, should be pretty straightforward. Y equals 3 to the x. Plugging in 1, you get 1/3. Plugging 0, you get 1. Plugging 1, you get 3. Very straightforward, right? Plot the points. Exponential function, we know how it looks. Remember, when things increase exponentially, that's sometimes like a term people use to describe how quickly something might grow. Like when people like, some people get sick or flu, but when it increases exponentially, people start getting sick very quickly. Or COVID, that's a great example. Like all of a sudden, 5 COVID, all of a sudden, 50 COVID, not like thousands of COVID, right? So you should expect there's a very sharp increase when you have exponential. A domain is always gonna be all real numbers because you put whatever you want for x, right? X be whatever. It's an exponent, who cares? But the range is limited because you can't raise 3 to some power and make it negative. Like what does 3 to some power mean? It means you multiply 3 repeatedly. 3 times 3 times 3 times 3 times 3, whatever, right? Even if it's a fraction, like if you have 3 to the negative 5 power, if I had 1/3 be multiplied, it's still gonna be positive. So there's no, and look at the graph, it's never dipping below the x-axis. So the range is definitely limited. And y equals 0, the asymptote is like a guardrail or boundary in a way. I want to be careful of that because we can cross those for rational functions, which we'll talk about later on. But or 1 over x, those kind of functions. But for now, it's just this boundary gets closer to. Now switch x and y. Don't solve for y because I haven't taught you how to do that yet. But what's gonna happen if you swap the columns, you plot those points, you get something that looks like this here. This green curve is the inverse. Notice how the green curve stays to the right of the y-axis. Now think about it. X equals 3 raised to some power. X has to be positive. If x equals 3 being multiplied a bunch of times, no way can x ever be negative. It can never ever be negative. It's going to be positive. So that's why its domain is that now. Its range, because y is the exponent, y can be whatever you want now. It's a free fall for y. Notice the domain and range swap, as they should for inverse. Domain is x, range is y. When we do inverse, we switch x and y, so domain and range naturally swap as well.
Does the asymptote switch too?
Yes, it does. It comes x equals 0.
Yeah.
Now it was y equals 0, now it's x equals 0, so now it's vertical. Also, the fact that if I were to superimpose these two graphs, you want y equals x to go right through the middle, which it will. It will.
Is this like what our quiz is gonna be?
Not today. No, today's going to be just find the inverse of a normal equation that we've seen already, like what we did on the walls.
Like this is like. you
Oh,
actually-
okay. Yeah, it is. I mean, it's more mechanical for the quiz today. Just here's an equation, swap x, y, and then move things around algebraically. That's quiz today. Like just did on the walls Thursday. Okay. All right. Okay. Well, any questions? We're okay with that? All right. I go a huge side because this is where things get a little complicated. Yeah. Okay. I'm going to make sure this is as painless as possible. Okay. It can get a little painful. But I'm going to do my best to make this pain-free. Right. And we're going to spend a lot of time on logs, a lot of time. Okay. So this is a big deal. This relationship, Lois, I need you to focus, please. Thank you. It's kind of the essence of algebra. I don't say it lightly. It is really kind of the essence of algebra too. If you ask anyone like, oh, what was the one thing that gave you a hard time or that just you remember from algebra 2, it's usually gonna be this. Just so you know, these are equivalent equations. X equals 3 to the y equals. Now, the way you say this, and it looks kind of weird. Let me get a highlighter out. If the highlighter actually shows. Not really. Okay. Let's go maybe purple. That might be better. I don't know. All right.
No.
Okay, so let's just forget about that. You say it like this. Log base 3 of x. That's how you say it. Log base 3 of x. What it's telling you is that 3 raised to the y power equals x. It's the same thing as that. 3 raised to the y power equals x. I know it's kind of weird, but why do we have it? We have it to help us isolate the exponents. So if you're curious about the purpose, like why, well, what's the purpose of log? Blah, blah, blah. It can, we get so caught up in the mechanics of it that we forget the real purpose of it as time passes. So I just want to make sure I intentionally tell you the purpose often. The purpose of a log isolate y after doing the inverse of y equals b to the x. That's the purpose. How to isolate y after you do the inverse. Logs are actually used to measure strengths of earthquakes. We had an earthquake last week. You guys remember in Daily? Yeah, it was, episode was 3.7 Daily City. I was stacked actually just work early in the morning. I felt the dining room jolt a little bit. And we could talk about earthquakes, the formula used for that later. But yeah, what was that? Yeah, it's called the the Richter scale, right? So like a 6.0, like a 7.0 is 10 times greater than a 6.0. That's using base 10. So I think that's just so it's easy to kind of keep track of magnitudes. Finance formulas, especially if you're looking at like investments, you have to use logarithms to figure out like how long you need to invest your money. So there's some good stuff there. All right, let's talk about this puzzle. All right, guys, quiet, please. Thank you. All right, so here's how this looks. It's kind of funny. So this is the same thing as 8 equals 2 cubed. This is the same thing as saying 27. So we're looking for patterns. Math is all about patterns, right? A lot of it's about patterns. Well, math is more than just that, but a good portion of math is. Okay, hopefully you see what I'm doing. I'm keeping the 8 where it is. I'm moving the subscript. I'm moving the subscript to the other side and raising it to a number that's on the other side. So 8 equals 2 cubed. 25 equals 5 squared. 27 equals 3 cubed. 10,000 equals 10 to the 4th power.
Wait, so the number under the log isn't the exponent?
It's a base. Yes. It's a base. Yes. That's the pattern. You're seeing the pattern. Good. Yes. Good job, Lincoln. So generally speaking, we write like this. Okay. So the B is called the base. That's the input. I know it's a little crazy. It's a little funky.
Really figure out the essence of algebra too.
It's more second semester, I'd say. Actually, the first semester is more about transformations. That was in quadratic. This is more second semester. So what happens is that things switch. So now this becomes the output.
Oh.
That becomes the input. And that's the base. So notice there's a swap, right? Now x becomes the output and y becomes the input. So these are the same thing. Y equals log base bx, the same thing as x equals b to the y. These are the same thing. For whatever the output and inputs were in the previous equation, swap. B we call the base. So whatever the subscript is the base of the power after you do the swap.
It's like a normal X.
Yeah.
squared.
Yep. It's like a normal x, 100% yes. Right. Oh, you can swear, it's fine. It is kind of weird. No worries, it's all good. Okay, so let's go through this drill. Because we're gonna keep coming back to this over and over again. This connection here. And actually we do kind of see this again in the second unit because we want to make sure you're getting enough exposure to this. I'm not gonna erase anything, I'm gonna switch colors. Okay, let's look at part A. So what you ask yourself is the following. What do you raise 2 to get to 16? How many times do you have to multiply 2 to get to 16? 2, 4, 8, 16. How many times do you multiply 2 to get to 16? I'm looking at part A here. Good. How many times do you multiply 2 to get to 32? 2, 4, 8, 16, 32. Yeah, 5 times. Okay, let's look at part C. 100 equals what raised to the second power? What do you raise to the second power to get to 100? What would you raise to the second power to get to 100? 10. Yep. Oh, good. Okay, the question mark will equal 5 cubed. So when you raise 5 to the third power, what do you get? 5, 25, 125. Okay, 81 equals something raised to the 4 power. What would you raise to the 4 power to get to 81? Yep, 3, got it. And lastly, for F, 10 so again, you take the subscript and you raise it to the other side. And you keep the number next to log where it is, or whatever x is. What would you raise 100 to get 10?
The 2,
-1.
the log 2,
Close. No,
the log.
it's a fraction.
How?
Yeah, 1/2. Because it's square root. Yeah, you're going to be very fluid with your fraction exponents too.
So wait, okay. On a test,
That's
do
not.
we get to use a calculator for this problem?
Absolutely not.
So
Nope.
we do all this mental division.
Four
It's
function?
hard to do addition, Mr. Alfonso. Like,
You made this far. You can do addition. Come on.
not real.
5 plus 3. You can do 5 plus 3.
Those are the stuff I
Eight.
use the calculator on the phone.
No, you're fine. You're pulling my chain. You just did D.
Or I guess for the past 3 of them.
You did B.
4 of them.
No, you okay. Mr. Davidson tells you don't give yourself enough credit. You're smart, you're great. No, I actually told you more than 3 times. I was in here when you tell you that. Okay. Okay. Here, let me sorry, let me go back. My apologies. Okay. Let's recap it before we do the next part. Let's recap it, guys. And then we'll guys we'll wrap the last page and you guys can start homework because I want to give you guys some time to start homework. Okay. 2 raised to the 4 power of 16. 2 raised to the 5th power is 32. 10 raised to the 2nd power is 100. Center, please. 5 raised to the 3rd power is 125. Raised to the 4th power, raised to the 4th power is 81. 100 raised to the half power is 10. Okay. Now let's look at 570. Okay, I'm gonna zoom in so you guys see a little better. Okay. Go ahead and try 570 on your own. Some of these are repeated from before. I'm gonna freeze the screen. And I think I'm gonna stop after this page so you guys can get started homework, because I think we can do the next page as a nice review next time we meet. Okay, guys, let's do 70. Stop talking. Thanks. Awesome. Yeah, we won't do page 14. We'll save that for next time. After I finish this, we'll start homework. We'll do the homework quiz. And you go, and if you have time, you can work on the sure, right? Yeah, so I don't want to. I want to make sure you guys have time for homework quiz. Yes, Evelyn, go ahead. You can't. Can't.
Wait, are we doing this yet?
Yep.
Oh.
And she like fully fixed them out.
It's not 16.
It's not one.
Yeah, some of these get pretty funky.
Fractions?
Some can be. Actually, none of these are. Actually, none of the answers will be fractions here.
What's A?
Okay, so I'll just write on the board here. Okay, so what you want to do is you want to read. So this will help. Keep the 32 where it is.
Yeah.
You guys, I'll help you guys out.
Oh, wait, that's so much easier to look at.
Yeah, I should have done that for you guys first. Hopefully you guys see what I'm doing. And guys, think of it this way, any side of parentheses, keep it where it is. The subscript, raise it to the other side, meaning make it the base of a power on the other side.
What's the power of 2?
What, oh, sorry, repeat this one.
No, nothing.
Okay.
Whoa.
How you do, Gabe?
You can't, it's undefined. Impossible. Because you can't multiply 2 a bunch of times and make it 0.
Oh.
Because in order for a product to be 0, you need one of those numbers to be 0.
Yeah.
But you just got a bunch of 2s.
Negative. One.
Okay, what's the?
So B is gonna be -1
The what?
Yeah.
because
Which one's not possible?
D
D. I thought.
is not possible.
Yeah,
Because
yeah.
you can't raise 2 to some power and make it 0, it's impossible.
Yeah.
Right?
But think of it like this, guys, and solve for the question marks. Okay, and after this, we'll do the homework quiz.
But like.
Oh. Another one. Yeah. What's 2 to the 1?
Just root 2.
What? Yeah, -1.
F is root 2.
Oh, wow.
Yeah, and I already wrote the answers. Here are the answers.
Here we go.
I have like so much energy right now. It's like not even.
So the answers are right there in red. For those taking chemistry, have you guys done acids and bases and pH? Okay, do you know the scale for pH?
Yeah, what is it, Alex?
It's like from 1 to 7, right?
That's for an acid, and then for a base from 7 to 14. If any of you guys have like a pool or hot tub, you have to measure the pH. It uses logs for that, just so you know.
It might be.
Okay. Any question on these? Yes, we're done. Yeah. Any question on these? Okay, so we'll do a homework quiz. We're gonna talk just so you know, if logs are still feeling iffy, it's okay. We're gonna talk about it again on Wednesday and a lot for the next few weeks, okay? Don't worry about it. If you're a little lost logs. It's a little funny. Homework's not too heavy on logs. All right. Okay, for the homework quiz, don't do number 2. Just do number 1.
What if we do it number 2 for extra credit?
You guys want to do that?
Yeah.
No.
More.
Little bit of extra credit.
Yeah.
Yeah, I can put extra credit towards. Yeah, sure. I'll do it. Why not? I haven't had you guys really practice number 2 yet, so you can do it.
2 points to get it right, 1 point to get it.
I'll do 5 points, not that.
How about 10?
5 points.
Yeah, 10 if you get it.
Give me an inch, something's about. Okay. You just have to do number 1, but if you want to do number 2, go ahead.
Yes, 113 from college.
That is the 13th. Yes. It is deep. And we're done. Just bring it up, and if you want to start homework, you can.
Why instead of FX for reason?
Sure, yeah, guys. You could use y instead of f of x. Actually, I prefer you do that. You replace f of x with y. Testing 1, 2, 3. Testing. Sorry. No, because I just disconnected from the speakers. Okay, stop recording.